Hello guys, we're gonna continue with science 6th grade, chapter 8, in this case lesson 3, earthquakes. We're gonna talk about earthquakes and tsunami hazard. Okay, you have a vocabulary over here guys. You have a stress, tension, compression, shearing, fault, earthquake, magnitude, tsunami, and you have just one word in academic vocabulary, in this case scale. All these words guys you have to underline in your test, in your book. You had to circle and label evidence that a tsunami occurred. Infer, how did the ship come to rest on land? Stress and earth crust. The movement of Earth's massive tectonic plate generate tremendous force. This force can bend and break the rock of Earth crust. The force that acts on rock to change its shape or volume is called stress. Underline this part, until stress. There are the three kinds of stress: tension, compression, and shearing. Underline the three kinds of stress, guys. Okay, what is a tension? It's the pulls on earth crust stretching the rock to make it thinner, especially at the point halfway between the two pulling forces. That's tension. Compression squeezes rock until it bends or breaks. Underline this part of compression. And shearing occurs when the rock is being pushed into two opposite directions to the point that it's bent or breaks. Underline that definition of shearing. This type of stress can produce both faults and faults. Movement on earth crust around faults can produce destructive earthquake and, in some cases, tsunami. Okay? You have a picture over here. Tsunami damage, figure 1, was in 2011. In major tsunami engulfed part of Japan, killed thousands of people and destroyed a lot of property. Okay, we're gonna talk about the faults. We have three different faults. The normal fault. A fault is a break in the rock, earth crust, or mantle. Most faults occur along plate boundaries where the stress of one or more type of deforming the rock leading to change of earth's surface. Underline this part guys. 1, 2, 3.5 lines. Then we're gonna move with the second fault, the reverse fault. Compression can produce a reverse fault in which the hanging walls slide up and over the footwall. Okay? Underline this part please, the first two lines. You have a picture over here guys, a dead valley. Tension can result in peak around the sunken valley, such as dead valley in California. Okay. Another fault, you have a slip fault. California San Andreas fault is a product of shearing. Underline this part please. Walls of rock ring past of each other in the opposite direction, making a slip fault. Underline until here too guys. You have guys over here a reading check. Complete this activity. Determine the central ideas. Pair of each fault type with the type of stress that produces it. You have two lines over here guys. Underline, complete the answer in the lines. Type of fault guys, you have a different diagrams and complete the diagram A and B. You have over here guys A, normal fault, and B, reverse fault, by leveling the hanging walls and the foot walls. Okay, and what part of the diagram, in this case normal fault, what is the hanging wall, and the other part, what is the foot wall? In the symbol letter B, reverse fault. In the diagram letter C over here, you have to drag an arrows to indicate the direction. What is the direction of shearing force and the moving along the fault? Valleys and mountains, that's figure 4. Take a look this, the rift valley and fault block mountains. Figure 4, as the tension pulled rock apart along normal faults, some block fault, like you see in the rift valley guys, and over time the resulting mountains weather. You see over here in the fault block mountains. new landforms from the plate movement. The first one is that tension and normal faults. To see how the tension and normal fault produce mountains, we need to zoom out and look at the series of the least two normal faults. Where two plates move away from each other, tension forms numerous faults that run parallel to each other over a wide area. Underline all this part, guys. You have 1, 2, 3, almost 4 lines, guys, please. The second new landform, folding. Compression within a plate causes the crust to deform without breaking. Folds are bent in rock that form when compression shortens and thickens earth crust. Underline from here, guys, until earth crust. And we're gonna continue underlining. Folds may be centimeters across or they may span many kilometers. The folds are often most visible and obvious when the rock is layered. Underline this part too, guys. Until layer. When folding occurs on a large scale, folds that bend upward become mountains and folds that bend downward becomes valley. You have academic vocabulary, guys. You have the question is the process of plate tectonics occur at different scale of time and shape. You have to list, guys, some different terms that are used to describe distance and time at vastly different scale. You have some lines over here to give me the answer, guys. Okay, we're gonna talk about anticline and syncline. A folded rock that bends upward into an arch is called anticline. Underline this part, please. Then we're gonna move on to here. The height of an anticline is exaggerated by the valley like syncline, which is a fold that bends downward. This is similar to the throw of a weight. Underline from the height until of a weight until over here, guys. Underline that part. You have a fold mountain over here in Hong Kong. UNESCO was a global geopark rebel. This thing falling pattern. You have another reading check over here, guys. The reading check summary text describe how both compression and tension can create mountains and valleys. You have some lines again and give me the answer over there, guys. Okay, the next diagram, guys, you have to label the anticline and syncline in the diagram. Okay, and what part is the anticline and another part, and what part of the diagram is the syncline. Okay, and you have another question. Identify limitation. How does this figure simplify how compression produces fold in earth crust? You have some lines again, guys. Give me the answer over there. We're gonna talk about the earthquake. Earthquake. Some plates interaction are gradual, quiet, and almost imperceptible. Others can sudden, violent, loud, and destructive. Underline this part, guys, about the earthquake. And you have the definition of earthquake. The shaking and trembling that result from this plate movement is an earthquake. Underline that part, please, too, guys. From the shaking onto earthquake. Continue underlining, guys. Some of the energy released in the earthquake is in the form of seismic wave. Underline this part too. Now we're gonna talk about the seismic wave. Similar to sound waves, seismic waves are vibrations that travel through air carrying energy released by various processes, such as an earthquake, ocean storm, and volcanic eruption. There are 3 types of seismic wave. You're gonna see in the figure 3. Underline, guys, the first 1, 2, 3 until eruption, volcanic eruption, until there, guys. Underline the 3 types of seismic wave. You will see over here, guys, in this different diagram. In this different diagram, guys, you had to use the particles motion in Earth's surface like P and S waves, you have to draw the particle motion for the surface wave. Okay, in what part of this diagram is the particle motion? The same over here. In this diagram, what is the particle motion? You have three different diagrams, and over here you have another diagram. And what part is the particle motion? And you have the same direction of the waves. Seismogram. The surface waves that travel along Earth's surface usually have the largest amplitude and therefore cause the most damage. You see a seismogram. The P waves travel fastest and arrive first, this part. The S waves arrive shortly after the P waves, is this part, guys, about the seismogram. And the last part of the seismogram is the surface wave produce the largest disturbance on the seismogram. Seismograph is a seismic wave produced by an earthquake and are measured by a device called a seismograph or a seismometer. Underline this part too, please, guys. The device converts the energy in different ways to visual are called a seismogram. Underline this part too, guys. You have another reading check. Determine the central idea. Why is it helpful for geologists to locate the epicenters of the earthquake? Underline that question over here, guys. Model it. You have a map of the United States, guys. For example, the figure 1 is over here. If you have a data from 3 seismograph stations, you can locate the precise location of the earthquake's epicenter. The center of each circle is the location of the station. In this case, Salt Lake City, Los Angeles, Santa Fe. The radius of each circle is the distance from the epicenter. The point where the 3 circles overlap is the location of the epicenter. Over here, guys, you have to draw an X on the map to indicate the epicenter of the earthquake. You have a graph over here, guys. You have to complete this table. Number 1, an analyze graph. Use the graph to determine the distance of each station from the epicenter. Record the distance in the table, okay? Number 2, question. Interpret graph. If another station is 5,000 kilometers from the epicenter of the earthquake, about how long after the start of the earthquake will the S waves have arrived at this station? What is the time? Will the S wave arrive at the station? Okay, magnitude. An earthquake magnitude, it is a single number that geologists use to assign to earthquake based on the earthquake size. The size of the earthquake is usually measured using the movement magnitude scale, which is a measure of the energy release. Underline all this part, guys, please, about the magnitude. You have another activity, guys. You have another table. Complete the data. You have to analyze the data and how much more energy were released by the earthquake in China than the one in IT. You have to take a look at this table. Okay, you have the earthquake potential around the world, guys. The lowest risk is color white and the highest risk is color purple. Okay, you have another question, cause and effect. What do you think accounts for the higher risk of earthquake in Los Angeles than Chicago? Complete that question over here, guys. Earthquake risk and tsunamis. The ring of fire around the Pacific Ocean is where many of the world earthquakes occur. There are many plate boundaries around the Pacific, including convergent and transform boundaries where stress builds up. Underline this part, guys. From the ring of fire until builds up. A tsunami is a wave of series of wave produced by an earthquake or landslide. Okay, underline the definition of tsunami. What is a landslide? Ocean floor uplift is one cause of tsunamis. Landslides are another one. Underline this part, please, guys, about the landslide. You have another reading check. You have a question over there. How can an earthquake or landslide produce a tsunami? You have some lines over here to complete that question. Okay, tsunami hazard, figure 13. The cider rock slide that produced the tsunami in Lituya Bay is marked by the circles. And what part of the photo? What is the Lituya Bay? And then you have to draw lines to indicate where the water splashed up and tore away plants and sediment from the bay shore. In the same picture, guys. Okay, remember, guys, the next page is the lesson 3 check. That's page 362. You have to complete that too, guys. Take a look the homework sheet I will send to you next week. These all activities, guys, in your book and the lesson check, you have to do it for Tuesday, April 28th. See you, guys.